Section 2.2 is on complements, subsets, and Venn diagrams. So we're going to learn what the universal set is in a complement of a set. We're going to discuss what subsets are, proper subsets versus just being a subset, and then the number of subsets of a set. So we just found out the cardinality is the number of elements of a set, so the question becomes how many subsets are there of a set. So what's the universal set? Well, it says the set of all elements that are being considered is called the universal set. So we will use the letter U to denote the universal set. So if we were in a classroom, this is where I'd have a discussion. I'd say, okay, if I said all students are getting an A, what do I mean by all students? Do I mean all students in this classroom? Do I mean all math students? Do I mean all students at the college or university? What do I mean when I say all students? So I need to narrow my focus and I need to make it clear who I'm talking about. This happens all the time. When you look at presidential things, because there's so much going on politically right now, they say, like current president is Donald Trump. Donald Trump's approval rating went down. Well, with who? And they try to claim that it's for the American people in general, but the question then is, well, were you, as a person, were you asked your feelings on Donald Trump? Were you there? So if you weren't asked, were you part of that set who responded? Okay, so that's my idea, is who are they talking about? What are they talking about? When they make claims, are they talking about everyone? We need to specify, and that's the whole purpose of a universal set, is to specify directly what you're talking about. I am talking about not all numbers, I'm talking about the numbers 1 through 10, for instance, the whole numbers 1 through 10. So you need to set what your universal set is. What are you talking about? So the universal set right here is what you are talking about. Okay, and that's what you're going to use the letter U for. Okay, so what's the complement of the set? The complement in the English language is different than a complement in mathematical language. Complement in English language means you look nice today. That's a compliment. I think you're a beautiful person. I really like your effort. These are all compliments that I could say to students, okay? A complement in mathematics, which is denoted by an A prime, and that's not the only way you'll see it. In other textbooks, you'll see it with an AC, or you might even see it with an A with a bar over it. Okay, all of these can mean A complement, but in this class, we're just going to use the A prime. That's what it means to be a complement. And it means the set of elements that are in the universal set, but not in A. So A complement to us is the set of all elements not in A. Okay, that's what A complement is. The set of all elements. Notice it is a set. The complement of a set is a set. So in mathematics, it means the opposite of. Okay, so it says let U be our universal set, the numbers 1 through 10. S is the set 2, 3, 2, 4, 6, 7, and T is the set of X such that X is less than 10 and X is an odd counting number. So if you remember, counting numbers start at the number 1. So the first thing I'm going to do here is I'm going to make T, I hate when it's written in set builder notation, so I'm just going to rewrite T and roster method here. So what is T? It's odd counting numbers less than 10, so that would be the numbers 1, 3, 5, 7, and 9. There's my odd counting numbers right there. So now that I can visually see that, I'm going to go ahead and get rid of that version of T, the set builder notation. That just confuses me. So it says find S prime. So how do you find S prime? Or when I say S prime, what I really, that's the notation, that's how you read it. But what that really means is the complement of S. So what this is saying is find everything not in S. That's what that means. So how do I do this? Here's what I always do, is I always start off with the universal set, and I just rewrite it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then what I'm going to do is I'm going to look at S, the set S right here. Here's the set S, and I'm going to remove every element that's in S from the universal set that I just wrote. So I'm going to cross off 2, cross off 4, cross off 6, cross off 7, and see what's left. Well, I would have the set 1, 3, 5, 8, 9, and 10. That's what would be left, and that is S complement, or S prime. You might hear me say prime. It's S prime, S complement, same thing. That is the things that are not in S, the numbers 1, 3, 5, 8, 9, and 10. So let's think about that. What if this problem did not denote what the universal set was? If it said find the complement of S, it would be everything that's not in S. Here we just wrote the numbers 1, 3, 5, 8, 9, 10, but wouldn't we need every single number ever? And everything else, even dog, cat, apple, pig, these are all things that would have to be in the set if we didn't establish our universal set. So you can't talk about the things that are not in the set unless you know the big picture. So in order to find a complement, you have to know the universal set. If you don't know the universal set, you can't find a complement. Let's go on and do example B here, find the complement of T. Again, we're going to start off by writing the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to go ahead and cross off. I'm going to go up to T and I'm going to highlight it. T was 1, 3, 5, 7, 9. So I'm going to go back to this and I'm going to cross off the numbers 1, 3, 5, 7, and 9. I'm going to look at it. What's left? It would be the numbers 2, 4, 6, 8, and 10. I've shown my work. I've gotten the answer. Let me put the answer in the answer blank. 2, 4, 6, 8, and 10. And there we are. Okay. It says, take note, to determine the complement of set A, you must know the elements of A as well as the elements of the universal set that is being used. Let's go on and try example 2, virtually the same thing here. It says, let U equal 0, 2, 3, 4, 6, 7, and 17. M is 0, 4, 6, and 17. And P is the set of X such that X is less than 7 and X is the even natural numbers. So is a even natural number. So it has to be less than 7 and an even natural number. Natural numbers, again, start at the number 1. So we would be talking about here the numbers 2, 4, and 6. Those are the even numbers that are less than 7. So the first thing I do is I rewrite P from set builder notation to roster method. Okay, let's look at M complement. Again, we would start off with the universal set, which is 0, 2, 3, 4, 6, 7, 17. Ooh, that needs to end in a brace. And then we're going to take off the things of M. So let me highlight M for you. Those are the numbers that I'm taking away. I'm going to take off 0, 4, 6, and 17. What's left are the numbers 2, 3, and 7 is all I'm seeing left. So that would be our final answer, 2, 3, and 7 in roster method. If it doesn't ask which method to put your answer in, always put it in roster method. Okay, P complement, again, we're going to start off with the universal set, which is 0, 2, 3, 4, 6, 7, and 17. We want to find the complement of that set, so let me go and highlight that set. P was the numbers 2, 4, and 6. So we're going to cross off the numbers 2, 4, and 6. Look at what's left. I see the numbers 0, 3, 7, and 17 left. Should be our final answer. 0, 3, 7, and 17. Excellent.